Alright, so this video is about derivatives of trig functions. So these are the 6 trig functions we're considering. Derivative of sine of x equals cosine of x. Derivative of tan of x equals secant squared of x. Derivative of secant of x equals secant x tan x. Derivative of cosine of x is negative sine x. Derivative of cotan of x is negative cosecant of x squared. And derivative of cosecant of x is negative cosecant x times cotan of x. So these have to be memorized. So you do want to write these down someplace. It's in your textbook as well. But you definitely want to actually get these written down, because you do have to memorize these derivatives. And now let's actually put them to use. So the first problem says find the derivative of y equals square root of x times sine of x. So this is product rule happening. So I know y prime should equal to the square root of x times the derivative of sine of x plus sine of x times the derivative of the square root of x. So that's true. Y prime should equal to the square root of x. The derivative of sine of x is cosine of x plus sine of x. And the derivative of square root of x should be 1/2 over the square root of x. And I can prove that using x to the 1/2 power and take the derivative of it. But it should be 1/2 and square root of x on the bottom of the fraction. And this is it. That would be the derivative of that function. So again, that would be the slope of the tangent line at any point. If you know the point, you can plug it in, and you can find the slope of the tangent line of this function using this derivative. All right, going further. All right, so the new example says find the derivative of secant divided by 1 plus tan. So if that's true, f prime x should be the denominator, 1 plus tan of x, times the derivative of the numerator. Subtract the numerator times the derivative of the denominator. And all right, so that says 1 plus tan x. Kind of hard to squeeze it there. Divided by the denominator squared. So if you're going to find the derivative of this, we should find it to be f prime of x equals to 1 plus tan of x. Derivative of secant of x is secant tan of x. Let's subtract secant x. And then the derivative of this function is, derivative of 1 is 0, so it's basically derivative of tan. So that's secant squared x. Secant squared just means secant times secant. That's what it means by secant squared of x. That's over 1 plus tan quantity squared. Alright, so this is kind of tight. I might have to erase this screen so I can finish this up, because I got some more multiplication here to do to simplify this. So if you would, pause the video, copy down what you can. I'm about to erase the screen and finish it from the top of the screen. All right, so moving on. So the simplified version of that previous step is this. So if you notice you got secant in both of these, you might start simplifying by factoring out a secant from each of these terms, which leads you to this expression, how you factor out secant from each one. You might recognize from trig that there's a formula that says, an identity that says, 1 plus tan squared of x equals secant squared of x. So if that's true, then tan squared of x subtract secant squared of x equals -1. So technically, this portion can be replaced with -1. So if that's true, I can rewrite this, which leads you to f prime equals to secant x times tan of x subtract 1 over 1 plus tan of x squared. Now you could square this, and you can try to simplify further. However, when I didn't see where it led to any meaningful simplification. So I'm leaving it here. So this would be the derivative of the function we began with. Anyway, that's it. That's all I have on that topic. I got one last example to talk about, and it deals with tangent lines. Somebody erase your screen. If you need to copy it, I'll pause the video. I'll write this down as a note. Okay, so final example. Directions say write the equation for the tangent line to the curve here at the point 0, 1. So, right, equation of tangent line, we know we need a slope, and we need a y-intercept, or you can use point slope formula. So just keep that in mind. That's our goal. That's what we want to find. So to find the slope, we need the derivative of this function. So y equals 1 plus x times cosine of x. It's definitely the product rule happening. So the derivative is the first function times the derivative of the second function plus the second function times the derivative of the first. So this is more neatly written as negative sine of x subtract, well, yeah, subtract x sine of x. You know, I'm just leave it there. I'm gonna leave it as this. 1 plus, just as it is. Because our goal is to find out where the coordinate is at 0. So if I want to find y prime at 0, I'll plug in 0 now. So this means 1 plus 0 times negative sine of 0 plus cosine of 0 times 1. So this should simplify to be should be y prime of 0 is, this is 1 times 0, so it's 0 plus 1. So y prime at 0 should be 1. Since I know that, I can now write the equation for the line because I have a point and a slope. So from there, you can now write y subtract y1 equals m times x subtract x1, which gives you y subtract y1, in this case, is 1, equals the slope, which is positive 1, x subtract 0. So it's y subtract 1 equals x. Add 1 on both sides. So the equation of the tangent line is y equals x plus 1. So I'll write someplace, equation of tangent line is y equals x plus 1. That answers the question. Anyway, I think that's it. That's all I have.